Okay, so we're going to see how we can use this to find the derivative of inverse trig functions. Okay, so we're going to start with y equals sine inverse x, and what I'm actually going to do is draw a triangle for that. Okay, y is going to be the angle whose sine is x. So draw yourself a triangle. My angle is actually y. And y is the angle whose sine is x. So sine is a ratio of what, two sides? Okay, so my opposite over hypotenuse needs to be x. So I'm just going to make it x over 1. Okay, so opposite of my angle, I'm going to put x, and my hypotenuse is going to be 1. Okay, so we have now drawn y. I didn't find out what it was, but I drew an angle whose sine is x. I'm going to go ahead and solve for the unknown side because it seems like we usually end up needing it. Okay, so how am I going to solve for the unknown side? Okay, and so I'm letting that be b. So b squared is, I'm just going to say 1 minus x squared, and then take the square root. So b is the square root of 1 minus x squared. Yes, I'm sorry, I'm not on the screen. Thank you, Megan. Okay, so this guy, I'm just going to get rid of the b now and make this the square root of 1 minus x squared. Okay, so this little triangle may help me a little bit in just a minute when I'm trying to get my final formula. Yes. Okay. See, my vision's fuzzy anyways, so you have to tell me when it's fuzzy. Okay. All right, so what we're going to do for this is we are going to take the sine of both sides. Okay, so first step is take the sine of both sides for this equation. Okay, so gentlemen, I'm going to take the sine of y equal to the sine of the sine inverse of x. The next step is I'm going to simplify that. Okay, so first step was I took the sine of both sides. Now I'm going to simplify that. So on this side, I just have sine y. Okay, what is the sine of sine inverse of x? They cancel out, so it's x. Okay. It sounded a little sleepy, so it was hard to hear. Okay, so now what I'm going to do is I'm going to take the derivative. Okay, and I've got a mixture of x's and y's, so I'm going to take the derivative. It's going to be implicit differentiation. So talk to me about the derivative of sine y. dy dx cosine what? Yes. I'm just going to write it in the opposite order of what you said it, but that's exactly right. So cosine of y dy dx equals, okay. Now my goal is to find the derivative, so I just need to solve for dy dx. So yes. Okay, that is the derivative, but I would like it to be in terms of x instead of in terms of y. Okay, and that's where my triangle is going to come in because this is cosine of y, and I have a triangle representing y, so I can substitute in what the cosine of y is. Okay, so if I look at this guy, cosine of y would be a ratio of what, two sides? Mm-hmm. So cosine of y would be, here's my adjacent, and my hypotenuse is just 1. Okay, so just the square root of 1 minus x squared. So this guy would be 1 over the square root of 1 minus x squared. And that's the formula that you're going to use to find the derivative of arc sine. Fortunately for us, it's on our formula sheet. We're not going to derive it every time. Okay, is that all right? Yes. Yes. Now, you can derive the other formulas. We're not going to derive them. Okay? So these are the formulas off your formula sheet. This tells you how to find the derivative of arc sine, arc cosine, and arc tangent. They're all found by doing what we did, making the triangles, taking the derivative implicitly, all of that good stuff. Okay? So now all we have to do is apply the formulas, which is usually way easier. Okay? So this one says find the derivative of the function f of x equals arc sine of x squared. So what I'm going to do is I'm going to look up here at arc sine, okay, and I'm going to notice that I'm not taking arc sine of x, okay, it's arc sine of x squared. Okay, so the difference is where there's an x, I'm going to substitute in x squared. And then what other rule do you think I might need to apply? Chain rule, right? So I'm also going to have to say times the derivative of this. Okay, so here we go. We're going to try it out. We're going to say, following this rule, 1 over the square root of 1 minus, and instead of the x, I have x squared, and then times the derivative of the inside function. So the derivative of x squared is, so that's the answer. I'm just going to simplify it. Okay, I'm going to leave the 2x in the numerator over the square root of 1 minus x to the what? Okay, so let's say you're doing something like the derivative of sine x. What would the derivative of sine x be? Cosine x. If instead of the x, I'm substituting in something else, so say like the derivative of sine of, what do you want? 4x, 2x squared? Okay, 2x squared. Then what you're going to do is you're going to just say that's cosine of 2x squared, but then times the derivative of the 2x squared. So that's what I'm doing here. So if you have a rule and you're substituting in something instead of the x, okay, you're going to keep that outer function, but then say times the derivative of the inner function. You're welcome. Because this would be like being times 2x over 1. When I say times the derivative of, so you saw where the 2x came from? Okay, so that's like having 2x over 1. So I'm just multiplying my numerators together and my denominators together. No. So this is like beside it. It's not under the root. So it's like this times 2x, not under the radical. So it's just 2x over 1. Is that all right? Okay. Question? 8 minutes. Okay, so keep moving. Is that what you're telling me? All right, here we go. This one has rules mixed together. Okay, so it's got arctan, which we didn't derive, and it's got an ln. So do you remember how to take the derivative of ln of something? 1 over x squared plus 4. So if it was ln of x, it would be 1 over x, yeah. Okay, so we do 1 over, and then what? Times 2x times the derivative of it. What'd you say, Bear? I couldn't quite hear you. Of the 2x? Okay. Yes. That's totally fine. In fact, you can do that all the time. Okay, so you're saying just go ahead. You know that's going to be in the denominator and the derivative of it's going to be in the top. That's great. Okay, so that's the first one completely done. Okay, minus, we're going to have the 1/2. Now, arctan, we're going to go up here and use this rule. Okay, So what we're looking at is instead of the x, we're using x over 2. So you're going to put x over 2 in anywhere you see the x, and then you're going to use chain rule, so it's going to be times the derivative of x over 2. Okay. So if we look at this guy, we're going to have 1 over 1 plus, what am I going to put in here? Squared. And then times the derivative of x over 2. What's the derivative of that? 1/2. You could use quotient rule. You don't need to because x over 2 is just the same as a half x. So the derivative is just a half. Okay, so let's just kind of clean this up a little bit. We have a half times a half, so that'd be a fourth. And still in the denominator here, we have 1 plus x squared over 4. And it seems a little silly not to go ahead and distribute out that 4. So we have 2x over x squared plus 4, and then 4 plus x squared, which it seems to me we already have a common denominator. So we might as well add those. So x squared plus 4, and in the numerator, 2x minus 1.
Okay, so first what you have to do is take the derivative of arctan. So that is so 1 over 1 plus the square root of x squared. And then you multiply that by square root of x, which I simplified or changed to x to the power of 1/2, which makes it easier to find the derivative of. A little louder? Okay. Sorry. Okay. Okay, so you use power rule, so you bring 1/2 down times x to the power of negative 1/2 multiplied by the derivative of x, which is just 1. So then you simplify that. Is it okay if I do all of that in one step? Okay, so you simplify everything, and then you end up with 1 over 2. Okay. Okay, so I'm going to have to bring. Okay, so this first off crosses out, so you have 1 plus x, and then you want to bring the negative 1/2 x down, so you're going to end up with this multiplied by 2x, and I'm just going to change that back to the square root of x, so 2 times the square root of x. Okay. Okay. Well, I didn't multiply it out anyways. Okay, cool.